Today I'm going to demonstrate Gay-Lussac's law. This law states that if volume is constant, pressure and temperature are equally proportional. This means when temperature rises, so does the pressure, and when the temperature drops, the pressure does too. To demonstrate this, I'll use 2 candles, green-colored water, a baking pan, and a glass cup. When the glass cup covers the candles, the temp in the cup rises, which raises the pressure. When the candles go out, the temperature and pressure drop, creating a small vacuum, which sucks water into the cup, as shown right now.
Today we'll be discussing Gay-Lussac's law and how it's relative to pressure and temperature. Gay-Lussac's law formula is P1 over T1 equals P2 over T2. P is pressure and T is temperature. Here I have a demonstration on how Gay-Lussac's law in theory will work. I have a can on the stove filled with 10 milliliters of water, boiling it, and a bowl of ice water. The law explains that if I lower the temperature inside of the can, I can also lower the pressure. On the outside of the can, with it not boiling, there's 14.7 psi on the outside and the inside of the can. If I dump it in the water upside down, I should lower the temperature on the inside, which should lower the pressure, and let's see what happens. Right now, the temperature on the inside of the can is 70 degrees Celsius, and the water, ice water, is currently 7 degrees Celsius. So let's see what happens when we dump it in there. As you can see, the can was crushed on the outside due to the pressure being greater on the outside of the can than it was on the inside. In our next video, Logan's going to explain how we did the math.
In Danny's video, the math, we were converting the temperature from Fahrenheit to Rankine. TI, temperature 1, while the candle was lit, was 70 degrees Fahrenheit. You add 460 to get 530 Rankine. Temperature 2 is when the water rises, which is 68 degrees Fahrenheit. To convert that, you add 460 and you get 528 degrees Rankine. Converting from Fahrenheit to Rankine is whatever degrees Fahrenheit something is, you add 460 to it and you get that Rankine. So for Jason's video, we're calculating the pressure. Pressure 1 is 14.7 psi, pressure 2 is not given. Temperature 1 is 343 degrees Kelvin. Temperature 2 is 280 degrees Kelvin. Up here, you got the whole equation. You got 14.7 divided by 343, which equals X, which is not given pressure, divided by 280. Cross multiply that, you got 343X equals 4116. And you divide the 343 on both sides, okay, and you get X equals 12 psi. Going from 14.7 psi to 12 psi created a pressure differential, or a vacuum, large enough to crush the can.